Hello! Welcome back to the spline constrained platformer tutorial. This is Blaster Toad of ToadNet, and I don't think I've got anything really to say to get started, big or inspirational. Kind of excited. Tomorrow, going out for crepes in the morning with a buddy for breakfast. Crepes are good. Yeah. Anywho, let's make games and stuff. So, loading in our test level. We've got stuff happening here, and we wanted to... What did I say we're going to do? Right, we are going to smooth this out and rotate the character. Right. Let's get class defaults. Rotate, 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 rotate to yaw. Oh, no. Character movement. Where is orient rotation to movement? Nope. Nope, where is, there has to be something about, rotating to direction of movement. But anywho, not important, because we're going to be overriding that anyway. So, first thing we're going to do is for our location and our rotation of the actor, we are going to lerp these values. We're going to move between one to another in a smooth fashion instead of just setting them like we are right now. Okay? For example, where we're going to see it in our project as it sits right now is as we go around here and watch as we continue to move forward, there is a point where Nuts jumps to the next spline. Right there. See that? Right there, where he hitches and jumps to the next spline. And we can fix that by being more precise on our splines, because our other spline, it links up like nothing. It's perfect. But this spline hitches right there. And we're going to smooth that out on the character and on the camera. What we're going to do is, off of our vector here that we're plugging in, we want to pull that over and we want to do a v interp2. Okay? And we want to plug this in target. And our current is going to be our get actor location. Arg, why do I keep pulling that up? Get actor location. Just like that. Okay. I'm going to straighten that. Delta time, we are going to do world delta seconds. And for interp speed, we're going to promote to variable. And we're going to call this interp location. Okay. And we're going to plug that in right there. And for our first value, we are going to, well, of course, compile and save to set that value. We're going to set it to 5 and see how that works. We're going to do the exact same thing over here, but we're going to do it with a rotator. So we're going to do an interp, and we're going to get an R interp2. Of course, this will again be our target. That will go in there. We're going to get the world delta seconds, promote to variable, our interp rotation, and then in current we are going to get actor rotation. Straighten that off. And this, again, we're going to set to, let's try 5. Okay. We're going to now do the exact same thing over in our camera, because our camera is also moving to a vector. So we're going to get rid of our print string that we have going on there. I'm going to straighten these up, and we're going to clean them up here in a moment. Let's just move this all down so we got space to do so. And then we're going to interp vinterp2. This goes in target. That goes in new location. Of course, our current location is get actor location. And delta time will be world delta seconds. And this here we are going to promote to variable, and we're going to call this just interp speed or interp location, because we may have different stuff happening on our camera later, dependent on how complex we make it. And on our camera's interp speed, let's again try 5. Compile and save. So now, if we start moving, our camera lags behind because we're interping, and our character is walking backwards and doing funny ass stuff. He's not rotating at all. Why is he not rotating? Because our character player interp rotation is too low, maybe? Get actor rotator, set actor rotator. Let's have our interp there, maybe like 20. Compile, save. Nope. Ooh, he's teleporting kind of all over the place. He doesn't know what he wants to do. Is that an issue with our location interp? Let's try setting location to 20. It likes moving along better with the location set like that. And you'll see as we go across here, well, as we don't go across here this time. Yeah, he's not rotating right. Current is get actor rotation, set actor rotation, teleporting physics. Our new target rotation is that. The only thing I can think of is if this is too low. We'll try it at a higher value. Nah, he's all over the bloody place. Get direction at distance, yeah. Okay, so maybe we don't set that rotation. And if we don't set that rotation, everything looks good. So we're still getting that jitter there, so we're gonna have this and set that back down to 5 and see how that feels. But we're gonna make our camera a little bit snappier, and we're gonna set our camera to 10. Let's see how that feels. Yeah, we drag behind the character less now. We're still getting that jitter. Ooh. And we are getting sliding locomotion, which we don't want. Let's turn that interp speed up. Interp location. on player character. Oh, I didn't set it up? I thought I set it up. Okay. Oh no, we set it back from like 50 to that to 5. So now we're gonna try 10. We get a little bit of sliding back. We get a little bit of snap there, but okay, let's try something like 15. And we're just trying to find that nice... So we still get a little bit of settling. But the character doesn't feel sluggish at all. The character seems to move like right away. And we're still getting some smoothing. It'd be interesting to see whether that jump is our character, or whether our character is moving smooth, and that is our actor, or our camera. But yeah, there's something about the way we have those two vectors joined that or these two not vectors splines, the way we have them joined up, that it's not liking. Gonna shorten these handles a little bit. Nope, that's actually a spline point. Is that a handle? Nope, that's the other spline. Yeah. So that's the issue right there. See how they're not quite lined up, so we're jumping from the one track to the other. And we just need to get that smoothed up. The camera, we may actually want to slow down then. We slow the camera down. So right now it'll lag behind the player by a fair amount. But it doesn't jitter as much as he moves. And then it kind of trails the character as he jumps. So if we move that to like a 4 maybe, and then the other thing we can do is we can copy get owner, and we can get actor forward vector, or no, we get velocity from the owner. And then from that velocity, we normalize. And then we multiply that by not another vector, by a float. And what this will do is it will give us a lead in front of the direction of travel. And then if we promote that to a variable, and we call that camera lead, and we get the new vector plus camera lead goes into our target. Let's see how that feels. It might help if we actually set camera lead to something though. So let's try to be 1 meter ahead of the character's travel. I was supposed to maximize. We're just kind of, you know, still trailing behind him, but not quite as far. Okay, well, let's try camera lead of 500. It might be a bit exaggerated. Yes, very exaggerated. And when we jump and when we fall. So 500's exaggerated. 100's not enough. Let's try 200. And we're above, and then we're below, and we're above, and then we look below. And then if we... Oh! Yeah, we need to adjust where that spring arm is, but I think that sort of camera works. So the next thing we're going to do is, if you notice he's turning in midair sometimes. Now we are going to set, we're gonna put that there. So follow player owner along spline and add lead distance. Okay. Compile, save. We're gonna go back to our player. And we are going to, yeah, that rotation it didn't like. So what we want to do now then is rotate the mesh. We're going to get velocity. We are going to normalize velocity. And that will be our forward vector. We're going to split that out and just get the Z. And from that, we are going to make a vector. Just the Z. We're then going to get actor up vector, and we are going to do an Z, X, and make rotate. Okay. And then if we select our mesh, it is rotated negative 90 degrees. So we need to combine rotators. And we need to combine negative 90 into the Z. And then we want to get our mesh, set world rotation. And we only want to do this if nearly equal, so vector nearly 0 by like 0.1. And we're gonna branch. And then we want a not nor, a not. I'm gonna plug this in. And we're gonna lower this down and straighten that out. And then here, I think, is where we're gonna want the lerp of the rotator, but we'll soon find out. What this is doing is, if our velocity is not nearly 0, okay, so if it is more than 0 in either direction, we are going to get its direction, but only the yaw, ignoring the pitch and roll. And then from that reference and the actor's up vector, favoring the up vector, and adding a 90-degree rotation, we are going to set the world rotation of our mesh. And what this should do is allow us to, if we start going forwards, it works as normal, as we expect, how everything has been. But if we go the other way, nothing happens. Why? Why, oh why, oh why. So nearly equal is not. Tick is valid, is falling. Either way goes into that, goes into that. Not equal, blah, 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 blah. Get actor up vector. Let's, not move that around. We want to print this Z value to see if it's actually giving me anything. Giving me 0 and 0. So the normalize is not working. Why is it not normalizing the velocity? Let's get our velocity and see what our velocity is each tick. Yeah, we have velocity. Oh. Because this would work if it was a rotation. So I just need to get rid of that. And we're gonna normalize. Straight into normalize, get rid of our print string. So basically, I was treating it like a rotator, but it's not. It's velocity, which is already a directional. We're just gonna plug that into our X. And now we walk forward and we walk backwards. And he flips either side, and when you let go, he stays in the direction he has last flipped to. But we want to do something more fun than that. We want to get our mesh, get world rotation, our interp2, our target goes into there, world delta seconds, and then we put in our interp rotation to here, and let's try a low value like 5. Compile, save. We should now see our little bot character turn to whichever direction he's moving. We may actually want that a little faster than 5, so let's try 10. So right now we're getting some camera things because our character is hitting the camera. But we can fix that. Actually, I don't think we're using the spring arm at all, so we could probably get rid of the spring arm. But, yeah. The character is now rotating, and I'm actually going to lower that down just a little bit. To say 8. He is now rotating into the direction of which he's moving, instead of just flipping to the direction that he's moving. And if he jumps into the bottom of something, he still gets a little funny. Ooh. There we go. So we're just going to clean this up a little bit. And we are going to comment this. And I think our comment on this guy is going to be rotate character mesh to direction of travel. Okay. Rotating the character mesh in the direction of travel. Awesome. So we're going to save that. And I don't know what the next video is going to be yet, but that's it for this one. Again, if you're wanting the project files, you can get access to them at the Patreon page, linked in the description below, so patreon.com/toadnet, and you can get access to the project files. And in this episode, we have, again, put a smoothing on the location of the player and the location of the camera. And we have set the mesh of the character to rotate to its direction of travel, so it doesn't look like he's moonwalking everywhere. Although moonwalking was fun. I'm going to file save all of that. And that is it for now. Whatever comes next, and we'll see you then.